Friends, good evening. Today I have tried twice to upload the video, but I don't know. My laptop is giving problem and the video timing reduced up to 1 minute. So again trying, let's see what can I do. Then now what is the system of finding out normal rated load current? That I'll show you, and the calculation I'll show you today. Let's see. Our incoming supply is 3-phase type. From there we are taking only 2-phase. Here I have shown red phase and yellow phase. It is going to the primary coil of the power transformer. Here it is 132 kV, and the CT secondary is connected with ammeter, overcurrent relay, IDMT and instantaneous, and earthfault relay. Now our rated load current is 163.6 ampere. When this will flow, then what will happen I am showing you. Okay, let's see. 163.6 ampere, when it will flow, what will happen? Friends, as circuit breaker operation is not required here, so I have omitted the circuit breaker in the circuit, but there will be a double pole circuit breaker before the transformer primary coil, and also in the 27 kV after the secondary coil. This is called transformer circuit breaker. One is HB transformer circuit, another is LV circuit breaker. Earthfault relay will trip both the circuit breaker at a time to make dead the transformer. So I have not shown the circuit breaker. To take power supply, first we will close the double pole isolator, then circuit breaker. So circuit breaker omitted. So first I will close the double pole circuit breaker. When the double pole isolator and circuit breaker is closed, then the 163.6 ampere full load current, if it is full load, it will flow in this way. See here, it is shown in the green color circle. It will flow in this way. And now see that how the CT secondary current is flowing. CT secondary current, how it will flow, I'll show it. It is shown in yellow color circle. Yellow color circle. It has been seen that when normal load current up to its normal load current or permissible overload current will flow, it will not enter the earthfault relay. It will not enter the earthfault relay till any earthfault if not persist in the 132 kV side. Any earthfault in the 132 kV side, the earthfault relay 1 will energize. But for this 27 kV side, it will not energize the earthfault relay of the 132 kV side. But if any earthfault in the 132 kV side, then its earthfault relay will energize and the CB will trip. Both the CB will trip. HB side and LB side transformers CB. So now during this normal current, it is not entering into the earthfault relay. But when this earthfault relay will energize, I'll show it now. Friends, we have seen that one earth fault occurred in the red phase after the CT. It is called restricted earth fault delay. Means CT to power transfer, if any earth fault is there, it is harmful for power transformer. So immediately it will trip both the circuit breaker. So in the figure we see that in red phase there is an earth fault. So when there is an earth fault, one part of current will return to the grid via the transformer coil and another will through earth to earth. You know earth is a good conductor. So when there is any earth, it will connect with the grid earth and current will return to the grid. So the current is divided in two parts. One is through the transformer coil of the primary and another through the earth to the grid. In the CT also it will be divided. A portion of the current will pass through ammeter and OCR1 and then return to the CT. But another portion that is shown in pink color, it will enter into the earth fault relay. As the current is divided in two parts and not returning these two parts to the source from the transformer primary coil, one is going to the other. In the delay also it will be divided. One will go to the ammeter and overcurrent relay to the CT, where it has come, it will return that CT, but it will not trip the overcurrent relay. Why? It is not a fault current. Earth fault current relay is very little, maybe very high, but our setting is low. We have seen it at 4.1%. If there is any earth fault near to this transformer, and it may trip overcurrent also if it is tremendous earth fault. So it will the small portion more than 4.1%, that means 0.204 ampere will enter into the earth fault delay or more. Immediately both the circuit breaker will trip to make the transformer dead, because earth fault near the transformer coil is very dangerous. It's very dangerous as there is no impedance, almost only the transformer impedance. The current will be enormous. So it will trip both the circuit breaker immediately. So if any query, please contact me in the above contact number and try to understand the working of earth fault relay. Earth fault relay will act when current is divided, one in the earth due to earth fault and another in the transformer coil. At that time the earth fault relay will act, and if it is in set value or more than it will trip both the circuit breaker of the transformer, both HV and LV, and make the transformer dead. Okay friends, good night. If you can't understand, please message me or call me. Okay, good night.